Hello, everybody. Welcome to week 4, where we will be continuing our discussion on algorithms for big data. In this week, we will be particularly looking at hashing and pairwise independence. Now, in today's context, when you think of data, where is it? A lot of us are storing it in the cloud. A lot of us have our data in Google Drive or Dropbox or Microsoft OneDrive, and we're getting used to running applications in the cloud. And what exactly does that mean? It essentially means that there is some large data center somewhere with lots and lots of servers, and your data is stored in one or few of the servers in this large data center. And when you need to access your data, you need to have access to this data center. But obviously, the company is not going to give you direct access to the data center. It's going to give access to your data through an appropriate interface. But in any case, that interface will have to know exactly where to look for the data, which server has it, and within that there's going to be a data structure holding data not just from you but from multiple people, and so all your data needs to be accessed very quickly, despite the fact that there's so much complexity behind the scenes. And how do you think that that happens? And the solution happens to be a simple technique called hashing. Hashing is essentially using a function to take any key value and map it to an address. And that address then tells you, I mean, that address could be the address of a server where your data is found, or it could be the address within a data structure where your data is found. In any case, hashing, as you can imagine, can be used in a variety of different ways, and a variety of algorithms employ hashing as a sort of a primitive. So now, in this week, we're going to try and understand hashing, and in particular, we're going to understand it in a very elementary way using the model of balls in bins. And essentially, balls in bins means that you have some number of bins and you have some number of balls, and you want to understand. I mean, you throw each ball uniformly at random and independently into one of the bins, and this is the experiment, and this, as it turns out, helps us to understand hashing, and you'll see how that works. So that's what we're going to look at in the first segment of this week's lecture. And then we're going to look at two different, shall we say, data structures that employ hashing. One is something you might have already seen before, chain hashing, but we're going to try and understand it from the perspective of balls and bins. And we're going to apply the balls and bins techniques to try and understand chain hashing. And chain hashing is essentially a dictionary. Given a key and a key value pair, you can hash the key value into your data structure, find a particular location where you can store the value, and then later on retrieve it. So it essentially is a dictionary ADT. On the other hand, we'll then continue to look at a new data structure, potentially something that you've not seen before, called the Bloom filter. A Bloom filter is a slightly different, simplified dictionary. It's not quite a dictionary. It's a data structure that answers set membership queries. What that means is that it tries to maintain a set of items. This could be the set of users in a large data center. Potentially, the set of all possible user IDs is a very large universe, and from that, some number of user IDs are actually used by people as they log into say a cloud computing system or something like that. Now the question is, suppose someone newly wants to to create a user ID, you want to know which user IDs are already taken and which ones are not taken. And this is essentially a set membership query. And Bloom filters help you answer such queries, even in a very compact way, even when the number of users is very large. So that will be the third segment of this week. And then we will move on to the notion of pairwise independence. So just to give you a context, by now you've realized that randomness is something that comes up in pretty much every big data algorithm. But one needs to realize that by good we mean mutually independent and uniform random bits, are actually hard to generate. There is no easy, clean way to do it. And essentially this comes from the fact that typically computers today are deterministic machines. But as it turns out, it's easy to extract large number of random numbers with a limited form of independence. We've already seen the definition of mutual independence. We will in segment 4 we will see a more limited form of independence. We will define what is called pairwise independence, or more generally k-wise independence, and then we'll try to understand what we mean and what the implications of that definition are. And as it turns out, it's easier to generate such random bits that have this limited independence. And then it's not of much value if you just know how to generate them but don't know how to apply them, right? So what we will do is then we will apply these random bits that have this limited form of independence, and we'll apply that to an application which is that of estimating the mean of a function via sampling. And so this is something that you might be able to imagine. So you're given a function, you want to estimate the mean, you don't want to look at every point of that function. So let's assume the function is not given in closed form, but rather given the only way you can get the values of the function is by querying it at different locations. Now, in a situation like that, sampling makes a lot of sense. What we will see here is how to use sampling using randomness that has this limited form of independence, and we'll see how we can effectively do that. So this is that will be segment 5 in this week. So with that, without further ado, please enjoy the segments this week. And let me remind you that if you have any questions, if there is anything that is unclear, please drop a note in the forum, and we will try to get back to you as quickly as we can. Thank you.